Okay, today we're going to take a look at, first of all, a beautiful tower. It is towering over everything here in the shop. Not really, but it does meet the requirements of the assignment. It is freestanding, not taped down to anything. It is above the minimum height, and it is stable. It's not, falling over, and it probably would stay nicely for at least 24 hours, right? So the task that I've got to accomplish today is to measure the height of this tower, right? And as described in my explanation earlier, the person doing the measuring, you, do not know exactly how far you are from the tower. And I've created a little circle here. It's not quite 2 feet in diameter, but it's close. To give you the idea of, I cannot take my meter stick or ruler or anything else and reach inside there to get a direct measurement of where the tower sits. Instead, I'm going to construct something to get an indirect measurement of that distance. So in the end, we're going to have 3 different methods for measuring the height of the tower. But we're only going to have one method for measuring the distance to the tower. Okay, so right now I have set up something, and the way I've done it here, you don't have to have these exact same things, these exact same tools handy to do it. It's just that because I have them, I'm going to use them, but you could do the same thing with your ruler or any other kind of straight edge, a piece of material, and accomplish the same thing as long as you have one ruler, which you have, at least one ruler that allows you to get a measurement going from from this line over to some point. Okay? So the first thing I've got to do is to look along this straight edge, in this case a meter stick, and down here and line it up carefully. And I've already done this, so you don't have to watch me struggle. But I've lined this meter stick up with the what I perceive to be a spot right underneath the center of the tower, right underneath where that. Really, I don't care about where the center of the base is. I care about what's right underneath that tippy top, right? We'll zoom in a little on that. Right there. There's the top of the tower, right? And I'm trying to pick a spot. Just look underneath it. Right about there looks good to me. That's where and I lined up my meter stick just so it's a straight edge pointing to it. Remember that I don't know how far the meter stick is from the base of the tower, or the center underneath of that topmost point. So what I want to do first is establish a known distance. And I'm going to establish a known distance that comes all the way out here to the edge of the table. Once I know how far the tower is from the edge of the table, from that point under the tower out here to the edge of the table, now I can do my other measurements in relation to that distance. If I'm a little further away with some point, a little closer with certain points, as long as my other points are not within the circle. Okay? Now, I've got this set up. I use this drawing triangle here. Let me zoom out a little. I use this drawing triangle just to make sure that these two straight edges are at a right angle to one another. Okay? So, this is a 45, 45, 90 drawing triangle. I've got these pushed up tight against the triangle. And now they're at a nice right angle to each other. And I just so happen to line up this edge here, this edge of the meter stick, this one, so that the end of it is right here, even with the edge of this straight edge, and it's flush with the edge of the table. Okay, that's going to make it easy for me, assuming I keep my tower in the same spot the whole time, right? Then I can do all my measurements from there. The next thing I want to do is to grab a protractor. Hopefully all of you have a protractor now, and what I've got on this protractor and what you'll need is a piece of string or a piece of thread, or you could even lay a ruler on here to establish this line, because what I'm going to do next, okay, I'm going to go ahead and put this on the put this camera on the stand now, and we'll try to get a nice view of me trying to do my measurement. Okay. What I'm trying to do is to lay this protractor on that straight edge at a known distance. I'm picking 60 centimeters from the end. So this is 60 centimeters at a right angle along the edge of the table from this straight edge that I've got lined up with the underneath of the tower, right? So that's good. Next, I'm going to take my protractor. Now, let's look at the protractor for a second. The zero mark of the 0 degrees is not even with this edge here. The center of this arc, and thus the part that lines up exactly with the 0 degrees, is this hole right here that I've got my string going through. Okay? It's not even with this edge here. That will throw you off. You want to be sure that you're lining up that little, there's even a center mark there to show you that's the center of the arc that creates a protractor. And as you go along here, 180 degrees or 0 or 180 over here, boom, 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 down here to 90, and then back up to 0 or 180 in the other direction. So that's another thing we've got to be careful about, is that when we set this up on the meter stick here, we get this nice and straight. I'm lining up the 0 marks with the edge of the rule, with the edge of the meter stick, like this. And then this string right here, I'm going to carefully sight along the string. I'm going to put my face down here and look along the string and get it to line up as best possible with that same point underneath the tower. Okay, so as I go down here, get ready to sight, keep everything straight with it, do like this. Okay, that looks pretty good right there. I would say yes. That's pretty good right there. Now, right now it's lined up with either 63 degrees, 63, 64 degrees, or 116. 64 or 116. Which one is it? When we look at the thing now, okay, so remember that number. When we look at this protractor, it's real easy to pick the wrong number. We came from here. This is the side that's lined up with the edge of the straight edge, and so when I come up like this, I've come up 64 degrees from the 0. I did not come 110 degrees from the other side. That's going to make a wacky triangle, given that we're creating a right triangle here, right? Hopefully you see that. Let me lay this down now. I'm going to put this back where it was, just for a second. Okay, and now I'm going to shift the camera around. Hopefully you can see my nice right triangle here. And of course then we've got a nice SOHCAHTOA, in particular a TOA calculation, to know how far away it is from the thing, right? So this is the base of my right triangle going along right here. Okay, here's the other leg of the triangle. And of course the hypotenuse would be established by this angle pointing towards that point out there. Okay, so if we say the tangent of 64 degrees would be the opposite leg of the triangle, this leg right here, over the adjacent leg. We know the angle, we know the adjacent distance, that's 60 centimeters, and thus we can then calculate the other, right? And of course you can look at this and say, well, it should come out, somewhere over 100 centimeters, right? If we do our calculation, it should come out somewhere over 100 centimeters, right? So we'll do the calculation, and I'm going to stop this in a second here. We should have a pretty good idea establishing this straight edge here, pointing towards a point underneath the tower, this straight edge at a right angle to it, this center of the arc of the protractor lined up on some measurement, and I've got that on this back edge right here, okay, because I'm going to use the edge of the table as my reference point, right? Well, my calculations may not be from this distance, but it'll be somehow related to this distance. Once I know that this is a certain distance from underneath that tower, I can use that distance to either figure out a distance closer or a distance further away, right, in relation to that point, and without ever reaching inside the 2-foot zone of exclusion, cylinder of exclusion. Okay? So that should work out there. I know that the string is a little fat. You have to do your best to line it up as best possible with a specific angle, right? You're probably not going to be able to do fractions of an angle with a string that's basically at least a whole degree fat on the scale. Okay, very good. Let's take a look here real quick. I have my mathematical calculation. Tangent of 64 degrees equals opposite over adjacent. Then adjacent times tangent 64 equals opposite. And when I did plug that in my calculator, I got a result like this: 123.0182305. Of course, if we claim that that's our answer, that's kind of ridiculous, because that tells us we've got this much accuracy to our system, right? And given that we used a protractor and we're measuring degrees to the nearest whole degree, it would be silly to add on that fraction to our result. So for simplicity's sake, we're going to stick with 123 centimeters from the edge of the table to that spot underneath the tower, right? So from the edge of the table there to the spot right underneath the top of the tower, we've calculated to be 123 centimeters. Now, when I go to use my protractor, what I'm going to do next is to calculate an angle of elevation. So I'm going to be looking at this line right here, which is even with the height of the tabletop, and projecting an angle, or projecting a line from somewhere right here up to the top of the tower, like this, right? And I want the center of the arc of the protractor to be even with the top of the table. Okay, so let's see how that looks. I'm going to put this on the stand and see if I can get a good view of how it'll look. Okay. Next thing I'm going to do, of course, when we take this protractor, let's take a look at it for a second. And we're looking at that, and we tilt it up here, we can read an angle right here. So right now, it says 70 degrees. Now this is a really common mistake, even though common sense tells us that this angle of elevation right here is not 70 degrees, right? Well, so when we put this back down to level, 0 angle of elevation, the string points at the 90, okay? So as we rotate it here, if I do rotate it 20 degrees, I'm lining up with the 70 and the 110. It's 20 degrees from 90. So our angle of elevation right there is actually 20 degrees, right? Real easy to make this mistake, especially when you get over here, whatever, and you get an angle that, or you're right in the middle, 46, 47, 50 degrees, whatever. It's real easy to guess wrong on that. So we go over here, and I'm picking a spot. Again, I'm going to line up with the center of my arc. The bottom side of this meter stick is the height of the table, right? And I've added some tape onto here just to hold it in place. I'm going to put this right on the 6-inch mark. And the mark over here at the edge of the table is the 10 inch mark. So when I go to put this up under here nice and snug underneath that 6 inch mark, that means I'm 4 inches from the edge of the table. So I'd add 4 inches onto that overall length from that point under the tower. And then when I go like this and carefully sight along this line, I want to get a nice angle of elevation going from the tabletop to the top of the tower, right? And I would say it's a little hard to do, but that looks pretty good right there. Right about there. Where is that on here? That is about, it's about 71 degrees. No, I mean 7, it's reading the 70. It really is reading right on the, I didn't plan that, reading right on the 70. So that means it's an angle of elevation of 20 degrees, right? Same calculation in this instance, tangent equals opposite over adjacent. We should know the adjacent distance. Now the adjacent side of the triangle is 123 centimeters plus, plus 4 centimeters here, right? And we've got a tangent of 20 degrees to get that. So we'll go ahead and do the math and see what that comes out to. All right, here we go. So I had tangent 20 equals opposite over adjacent. Tangent 20 equals opposite over 127. It was 123 plus 4, 127. Then 127 times tangent of 20 came out to 46.224, 1 blah, blah, blah. So we said 46 centimeters equals opposite, which is the height. So the height, our calculation of the height based on this indirect measurement system is 46 centimeters. Okay? Good.